Hello, Rani ma'am, you're there?
Yes, sir. Tell me, sir.
Yeah, ma'am, can we start? I think it's already 11:30.
Yes, sir. 2 minutes, sir.
Yeah. And can you tell me what has been covered till now from yesterday? What are the topics? Hello, Rani ma'am, are you there?
Yes, sir. Yes.
Yeah.
Sir,
Can you
session
please?
one,
Uh-huh.
overview of image processing application.
Okay.
Session two,
Hmm.
workflow and application of image processing using MATLAB.
Okay.
Session three, deep learning approach for image processing using MATLAB. And
Okay, ma'am.
morning session four
Yeah.
on deep learning architecture and their applications.
Okay. Was ANN also covered in that, artificial neural networks?
Uh, yes, sir.
Okay.
Oh, can we start now, sir?
Yeah, please.
Yeah. Thank you, sir. Thank you, sir. Good morning, everyone. I would like to welcome our speaker of session 5, Mr. Arunjit Chaudhary, CEO, Enterprise Building Training Solution. Mr. Arunjit Chaudhary is providing assistance in teaching students in latest trends in information technology aligned to the industry needs. He is having a rich experience of 25 plus years working in IT industry for tier client across US, Europe, and Asia Pacific, and Haprun expertise in managing global team, delivering the software projects, is certified in sales and distribution module with SAP and certified Scrum Master from Scrum Alliance, and he has trained students across 65 plus colleges in latest IT trends. Now you can go through with the section, sir.
Okay. Thank you, ma'am, for the introduction, and good morning to all of you. Let me just share my screen just to make sure that you guys are able to see it. Is my screen visible to all?
Yes,
Yes,
yes.
sir.
Okay, thank you. Let me just bring up a few things.
It's visible, sir.
Yeah, thank you. Let me just set up a few things here and there. Okay, so today I'll be covering two sessions, but my main focus will be doing some hands-on using Python. So I'll be the first session, which is the morning from 11:30 to 1. I'll be covering some of the machine learning models. And then in the afternoon, I'll be going through I will basically try to cover more models from the machine learning perspective, and then also cover the ANN. But ANN probably can somebody tell me has the ANN architecture been covered from the audience? I request all of you to please participate.
No, sir. No, sir.
So ANN has not been covered. So what has been covered in your deep learning architecture?
They gave just an overview of what is deep learning, and he
Okay.
explained us about.
Okay. So he has not gone to the details about the AN architecture, right?
Yes, sir.
And I just want to make sure that there is no duplication. So I thought I'll just get this clarified before I start. So few things before I start, all of you, is let's try to make this session as engaging as possible. So please unmute and speak whenever you have questions or whenever you have some thoughts to share, because this is a collaborative session. We all need to learn from each other. And of course, whatever little I know, I will try to impart my knowledge. And obviously, I expect all of you guys from different capacities to also share the knowledge for the benefit of all. As far as possible, try to unmute, or you can also share your questions on the chat. You can interrupt me at any point of time, but let's not make this a monologue session where I just speak and you guys are quiet. So I want a total engaging session. Okay. And while you guys have, many of you have already gone through image processing and what is the details of image processing and how, you also heard about deep learning. So let me start off with some basics, and then I will get into some machine learning models. I'm going to show it on Python Spider, which I've kept it open on my screen. I will run a few scripts. I'll show it to you. I will share the scripts with you at the end of the session so that you can also practice as per your convenience. Okay. So the way I would like to start is the topic talks about workshop on machine learning models, regression and classification. So I would like to first understand from anybody of you, what is your interpretation of machine learning? Can anybody tell me, or can anybody put his perspective from an industry standpoint, what is machine learning?
Excuse me, sir, may I?
Please, and my small request, please tell your name before you speak so I come to know who is speaking, right? If you don't mind. Yeah, please. Yeah, go ahead.
Yes, sir, sure, sir. Myself, Mr. Vipul Kondekar from Walchand Institute of Technology, Sholapur.
Yes.
So, according to me, machine learning is the area where we are trying to develop a program by providing the input and desired outputs to the system itself.
You are right. You are saying develop a program to get a desired output based on inputs, correct?
No. Get a desired output is one thing, but we have some outputs known,
Okay.
and the inputs and corresponding outputs are given as the input to the system, and whether that system could come up with the program, so that would be a machine learning.
Okay. Priyank talks about input output provided algorithm learned by machine. Input output provided algorithm learned by machine. Very good. Okay. Anybody else?
Yes, sir. I'm Dr. Swapna, sir.
Yes,
Sir,
Dr. Sapna.
so we train the model by giving the data, existing input and output data. So the model gets trained, and we can predict the unknown data output by giving the unknown input to them. So I think that is the motive of machine learning.
Okay. So I think you have made a good point here. So number one, we are saying here, see, first of all, when I'm talking of machine learning, the first and very most important thing is you need to have data, right? You have to have some input data on which you want to use a machine learning model and basically use the data to train the machine, right? And typically, as anybody is saying, there is an input and an output, right? Okay. So what happens in machine learning, and that's the way I would like to put it, is first of all, when you have an input data, you are going to train the machine with the data, right? Using the data. And the objective is basically, if you're having an input and output, the objective is to derive a pattern out of the data. And this word is very, very important. Okay. How do you derive a pattern out of the data? When I say pattern, trying to develop a relationship between the input and the output. So that is how we are deriving a pattern out of the data. And based on the date pattern, as ma'am rightly said, you try to predict the output. or a new set of input data. Or a new set of input data. Okay, so once you have some data, that data is, you train the machine with that data, the machine get trained, and as it learns through experience, that's a very important word. And learning through experience, right? Please ignore my spell checks. Let's focus on the contents. So you train the machine using the data, and the machine learns through experience. And as it learns through experience, it tries to come out with a prediction of the output. And this prediction of the output is based on the relationship between the input and output, based on the learning you have gone through the training data. Once you are able to come out with a pattern, so for a new set of input, you should be able to predict the output. And this output, predicted output should be close to the actual output. Actual output. Okay. So when you have a new set of data, so whenever you have trained the machine or the model with the set of data, and the model has come out with a pattern, it should be able to predict the output for a new set of input data, and that output predicted about should reflect the true data or should be close to the actual data. And this is how I will define machine learning, right? Now in machine learning, can somebody give me some examples of machine learning? Day-to-day examples?
Sir, one example is to train a child to identify a fruit, like whether it's an apple or whether it's an orange. This is one of the example.
Okay, you're training. Okay, fine. It's more of a lives. Okay, fine. Okay, from a
So one example is related to our e-commerce shopping. Whatever
okay.
we are seeing in the search, they predicted and they give us the suggestions related to those based on their search.
Very good. So your product recommendation is an example of machine learning. Very good. What else? Cancer prediction. Very good. You want to predict whether a person is having cancer or not based on certain set of input variables. That is also an example of a prediction learning. Healthcare system, skin disease classification. Okay. Speech recognition. Yes. So speech recognition, essentially, we are talking about natural language processing. Basically, can anybody give me an example of speech recognition? If you talk of Alexa, Alexa is again an example of recognizing the speech, converting into text. So that's again running through a machine learning algorithms, right? So Alexa is an example here. Character recognition, yes. Okay, character speech or character recognition, yes. Handwritten
Weather
text
forecasting.
recognition. Weather forecasting. Okay, yes. Google search is one of the most common examples of machine learning. So when you do a Google search and you search on a particular text, there is a machine learning algorithm which tries to come out with some set of intelligent searches, because there's an algorithm which goes through all your searches and tries to come out with a new set of searches, right? So that is again using machine learning algorithms. Then you also have even movie recommendation in Netflix, right? That is also an example of machine learning. There are multiple examples. What else?
Driverless cars, stock market estimation.
Driverless cars. Very good. Can somebody tell me how does a driverless car work? Can somebody tell me how does a driverless car work?
No, the technology might be they are using some sensors. Means if driver is
Yes, very
not there,
good.
so ultimately sensors will help you and they will give you idea about the surrounding situations, and based on that, the car is taking the decision.
So one is the sensors, very good. So sensor is used for object detection, right? Then obviously you have cameras, which is used to basically capture the lane in which you're going, the traffic lights. Okay. Then you also have GPS where it will navigate the direction you have programmed. Okay. Yeah. So driverless cars, it's a combination of deep learning, mainly using deep learning, where we use convolutional neural networks for image processing. Okay, and obviously for object detection, if you have a person in coming front of you, using an object detection, using using machine learning, you were able to detect the object which is in front of you and take an action, right? So these are all examples of the machine learning driverless cars. Okay. Then in mechanical also, if you want to predict a particular object is defective or not, so you can capture the image and then you compare it with the image which is already, as the machine goes through, as capture that image, you can compare it and say whether that particular a particular image that you are projecting is an actual defect or not, the particular product is defective or not. So that's another example of machine. So there are innumerous examples of machine learning. Another example, it could be the chatbot, very popular. So any website which runs on a chat has a chatbot, right, where you can ask questions and give answers. So those again runs on machine learning algorithms, right? So there are multiple such examples. Now, are you guys aware of the various machine learning types, supervised and unsupervised learning? Has this been taught to you in your previous session?
Yes, sir.
Okay. Can somebody tell me what is the difference between a supervised and an unsupervised model?
So supervised model is that in which we have trained the machine before applying any input. We first train the machine, then after, based on that data, it respond. We ourselves trained the machine before use. And in
Okay.
unsupervised learning, machine learn by themselves with their experience, and then he started responding.
No, I don't think that is the difference here, because in both the cases, you're going to train the machine and the machine will try to derive a pattern, right? But what is the main difference between supervised and unsupervised?
But in supervised learning, when you have the data, data is a labeled data, so outputs are known initially. In unsupervised, unlabeled data you have.
So in the case, very nice. So in the case of supervised model, essentially what happens is that the pattern of the data is known in advance. You know the pattern of the data. So for example, what are the types of supervised learning? What are the two main types?
Categorical.
No. When you talk of supervised learning, so there are two main types. So one, you have regression.
Classification and regression.
Classification and regression.
Correct. You have regression and classification, right? So what is the difference between regression and classification?
Regression, you have, continuous data you should have in case of regression, and you will get an equation or a model to predict the future. Classification means you just classify as this one or that one, this stream or that stream, like 0 or 1 or something like that, sir. You classify yeah.
Right. So when you say regression, let's say if I have an equation of y equal to mx plus c, right? And we know that this is a straight line. Okay, this is what we have all learned in our childhood days, in our algebra in schools. Okay, now when you have such an equation, and when you know that the pattern of the data is known, you know that you will have a straight line, you have a proper correlation between y and x, where y, what is y called in machine learning terms?
Output.
What is y?
Predicted output.
Y is the dependent variable, sir, and X is the independent variable.
Very good. So y is called the dependent variable, x is called the independent variable. There are some other terms also which are used. We also call dependent variable as output, right? That's correct. Now we also have independent variable. We also call it a feature, and sometimes we also call it a predictor. Okay, that's how it's. So what is M?
M is the slope.
M is the slope, correct? But in machine learning terms, it is called coefficient. Okay. When you talk in machine learning language, it's called coefficient, right? And when you talk about any supervised learning, you will have one output, which is y, and you could have multiple inputs, which are x, right? So in that case, you have what is called a univariate regression, where you have got a single independent variable, or you have a multivariate regression, you have got multiple independent variables. Can somebody give me an example of a multivariate regression? Can somebody give me an example of multivariate regression?
Any process, sir, where you have lot of independent variables. For example, you want to know the efficiency of an engine. This efficiency affected by number of variables. So you have multiple variables and one output, the efficiency.
Correct. Yeah, but yeah, I mean, okay. But can you give me a concrete example? You're right. I mean, your direction is absolutely right. But can you give me a concrete example of a multivariate regression? Suppose I have a price of a house, right? Now, my price of a house can depend on various factors, which is the size in square feet. It will depend on the number of bedrooms. It could also depend on the floor in which the house, the age of the house. Could also have a proximity to the main road, or proximity to the mall, right? So these are the various features. Okay, these are the various features which decides the price of a house. Similarly, you have a price of a car. A price of a car can again depend on various features. It could depend on the mileage it gives, the engine, the compression ratio. There could be multiple mechanical factors which could decide the price of a house. So these are the price of a car. So these are all the examples of a multivariate regression, right? And what is classification? In the case of regression, the y is a continuous variable. That means the y changes as x changes, right? But in the case of classification, your y is a fixed set of values, or it is a categorical values, fixed set of categorical values, right? So it could be, as someone said, it could be 0 or 1, or I could say that it could be a set of images, whether it's a dog, cat, or horse, or it could be whether in diagnosis perspective, whether somebody is having cancer or somebody is not having cancer. So these are two examples. So you could have a fixed set of values, and that is where you define what is called a classification. So the main difference with regression and classification, which are part of supervised model, is while regression is having a continuous output, classification is having a discrete output, right? That is one of the main differences. Okay, and the classification, there could be many examples. We talk about image detection, image recognition, or you could also talk about a traffic light, whether it's red, yellow, green, or blue, right? That's where you use algorithms in driverless cars to identify a particular traffic light and take an action based on whether it's red, blue, and green, right? Red, yellow, or green, sorry. And then you also have cancer detection. So depending on the number of features, you can decide whether the person is having a benign cancer or a malignant cancer, right? So that could be again multiple set of values. So these are multiple examples of classification also is possible. When you come to unsupervised learning, one of the primary thing is that you don't know the pattern out of the data. You have the data, but you can't make anything. You cannot make out apparently what is there any correlation between the various variables. Okay, and typically you will not have an output and an input in an unsupervised model. Okay, if you have an output and input, then it becomes a supervised model anyways. So in an unsupervised model, you don't know the pattern out of the data, and you need a way to go to the hidden patterns and try to find out some relationship between the data. And let me give you an example. I'm the mall owner. We have got various malls, right? There are various shops in there, and there are people they go and do a lot of shopping there or various types of products. I am the mall owner, and I want to come out with an advertising campaign. And that advertising campaign could be for a specific set of customers. So what I do is, for every customer which I come in, I will capture his age. I will capture the salary, sort of a salary that the person is drawing. And also I'm capturing what is called a spending power. Now this spending power determines whether a person is a lavish spender or is a conservative guy, is a thrifty guy, right? So if higher the spending power, and this is sort of an equation which can be derived based on the number of products he has bought. Okay, so you could have so you collect various such data for the various types of customers. Okay, so maybe somewhere where it is 80 to 100 could be a very lavish guy who spends a lot. He likes to explore new products. Somewhere between 50 and 40 and 80 will be somewhere a conservative, and somewhere between 20 and 30 could be the guy who are very, very cautious before they spend. Okay, so once I capture this spending power, then what I do is I try to group these customers, and this grouping is done by me as a data scientist depending on the problem statement. So if the mall owner wants to come out with some advertising campaign, then I will probably group customers based on maybe say high salary, high spending power, high salary, low spending power, or you could have medium salary, high medium salary. You can define what is the medium salary or high, and high spending power, right? So I could do various categorization. Now this particular categorization in machine learning terms is called clustering. So I create groups based on common attributes, and based on that I try to derive a pattern based on the group, which says maybe what is the percentage of people are in the bracket 1, this bracket, what is the percentage of people are in second bracket, what is the percentage of people are in third bracket, and then based on this I try to formulate a marketing campaign. So if there's a guy with high salary and a low spending power, I will probably come out with a promotional campaign and say buy one get one free. If a guy is having high salary, high spending power, I can come out with a strategy where I can introduce new products, because he will not mind trying out new products and spending on that, right? So that is how you work on an unsupervised model. So this typically is called clustering. And the other one which is there, it is called the learning association. And this is typically the recommender engines that you're talking about. that is your movie recommendation, your LinkedIn job recommendation, your your product recommendation in Walmart or Flipkart. All these are examples of a recommender engine, and this is working through an unsupervised machine learning model. Okay, that is called learning association. So these are the two examples of unsupervised, and the third type is the reinforcement learning. And reinforcement learning, the best example is robots. The robots that is working today in most of the factories, in the shop floors of major automotive companies in Japan or US. Okay, they are all working based on reinforcement learning, and that's a very different topic altogether. It's a very complicated topic, but again, this is the third type of thing, which is called reinforcement. So you've got supervised, unsupervised, and reinforcement learning, right? So any questions at this point of time? Can I get a quick yes or no on the chat board if you have understood?
Sir,
Yes, if you're not.
once you give example of all sets, just supervised learning, non-supervised learning, and reinforcement learning.
Little bit more about reinforcement learning, sir.
Reinforcement learning is a different topic, but I will just give you okay. So in reinforcement learning, you have something called an action. The action is basically, if I'm looking at a robot will take an action and it will move from one state to another state, right? Now, as it moves from one state to another state, okay, if it takes the right action, means, for example, this robot is supposed to do a particular operation, and if it does that desired operation, then it gets a reward. Okay, and if it doesn't do the desired operation, basically you get a penalty. So reinforcement learning is something called continuous learning. So at each point of time, whenever you make a mistake, you try to learn from that, and at each point you when you move from one state to another state, the idea is how you can maximize your rewards and minimize your penalty. Okay, so there are some algorithms like the Markov decision processes. There are various other algorithms which are available in supervised learning, in reinforcement, which is not in the current scope. But this is how it works. It basically works on the concept of rewards. How do you maximize rewards, and how do you minimize penalty, right? So there are various such algorithms available for reinforcement learning, right?
An example of supervised and unsupervised. Sir, also one second.
Unsupervised, I gave you this example of the mall owner, right?
Mall owner. Continuous.
No, this is unsupervised.
Unsupervised.
Yes, and when I talked about supervised, I told you in supervised you have regression and classification. I gave you an example of a regression, right? Where you have a multivariate regression. And in classification, I gave you an example where you have a discrete set of variables. For example, multiple features can decide whether a person is having cancer or not having cancer, right? So that's an example of a classification. Okay?
Thanks, sir.
Okay. Now I'm going to go, before I get into some scripts, I want you guys to understand of how does a model workflow work in a supervised model. My focus today is only going to be on supervised. Now, please pay attention to what I'm saying, and this is what I'm going to execute in the scripts, which I'm going to do it in course of time. So number one, we all know that we have got some input data on which you have to come out with a machine learning model. So I have some input data, and that input data, suppose I am the HR manager of a company, I am the customer, and I have got the years of experience. I want to capture the years of experience and have the salary of my employees. And I need to come out with a machine learning model which will help me to predict the output, predict the outcome, which will be in line with the input data. So I want to come out with a machine learning model which will be able to predict the salary based on my years of experience. Okay. Now, when you have years of experience and salary, which is your independent variable? So when you have years of experience and salary, which is your independent variable?
Experience.
Sir, experience.
Yes. So years of experience is your independent variable and salary is your dependent variable. Okay. Now imagine that the HR manager has come to me as a data scientist or you as a data scientist, and then he has given you data and is asking you to come out with a model. Okay. Now prima facie, you know that this is going to be a regression data. Why? Because typically when your years of experience increases, your salary also increases, right? Because
Continuous variables, both are.
No. Yeah. So continuous variable is continuous variable is a dependent variable, not the independent variable. What we are concerned is the dependent variable. So this is continuous, right? Perfect. So you have a continuous variable in the case of regression. Okay. Now you have got say around 1,000 records of this data from your client. Now typically what happens when you get the data, you cannot directly process the data. Because typically when you get the data, there could be a lot of errors in the data. You could have situations where there is a missing data. You have got situations where there are outliers. You know what is an outlier?
No, sir.
Outlier basically which is not in range. So for example, if I say that if I have years of experience and salary, I cannot have a years of experience of 70 years. Okay, neither I can have a salary of say 10 rupees. So these could be outliers, right? Which doesn't fit in the normal set of values, right? So I have to eliminate outliers. I have to eliminate null values. I have to eliminate missing data. So typically when I work in a project, in a data science project, there are 4 phases. One is the data preparation phase, where I collect the data, I pre-process the data. What I call, I pre-process the data. So I need to take care of null values. I need to take care of outliers. I need to take care of missing data. So this is very, very important that I have to pre-process the data. Once I do my data processing, that's called the data processing phase. And typically in any organization, 60 to 65% of the time is spent on data processing phase, because that's the most important phase. If your data is not correct, your model will not give you the right answer, will not predict the right output. So once you have done the data preparation phase, then the next stage is called the modeling phase. So what I do is that I train my machine using learning algorithms, and I train the data. Train the machine with the data using algorithms, and then I try to come out with some patterns. Once I done the model, then I do a model evaluation where I try to test the model for the accuracy. And then finally, I do a model deployment. I deploy the model at a client location. Okay. So in the data pre-processing, as I said, in the pre-processing phase, I need to take care of all these null values, missing data values, and so on. And then I need to split my data into training set and test set. Why is this required? Anybody? Why do you need to split the data?
सर ट्रेनिंग सेट इज द होल डेटा, मतलब जो सारा डेटा यूज करना चाहते हैं उसे लर्न करवाने के लिए एंड टेस्ट सेट फॉर देयर जस्ट एज एक्सपेरिमेंट, स्टार्टिंग में चेक करने के लिए कि पूरी तरह से सही है.
Okay, so what we are saying is training set is basically used for training the model, and the test set is to check the accuracy of the model.
Yes, sir.
Right? And the test set is different from the training set. They are 2 exclusive sets. Okay, so test set is never part of training, and training is never part of test. Okay, and typically in an industry, the split should be minimum 70% training and max 30% test. So it could be 70-30, it could be 75-25, 80-20, depending on the number of records you have. But always remember the more the data you have for training, the more better the prediction will happen. Okay, and typically the last thing you should ever do is to delete any data. You should never delete any data, because that will, unless it's really mandatory, because there are some values you don't have the values and you're not able to get the values. Otherwise, you should never try to delete any data. That is the last option. So you have a 70% training and 30% test set. So what I do is, this 70%, that is 700 records of the training set, I basically train the machine, okay, and then I come out with a pattern. When I say pattern, I get a pattern where I have a relationship between the dependent variable and the independent variable, right? Once this is done, then I take the test set. Now, what I did in the test set is that I take the independent variable of the test data. I take the independent variable of the test data, I feed it into the model, and then I come out with a predicted salary. Since the model has already been trained here and it has derived a pattern, I take the 300 records which has not been tested before, which has not been used before in the model. I input the independent variable or variables into the test data into the model, and come out with the predicted output. In this case, is called the predicted salary. And then I compare the predicted salary with the actual salary of the test data. You already have the actual salary of the test data, and I do a comparison between the predicted salary and the actual salary. And if my efficiency of the model, that means how close the predicted value is to the actual value, is typically, if it is more than 85 to 90%, I can say that this model can be recommended to the client. Please note that you can never get 100% accuracy. We have all been trying, but after all, it's not a there's a lot of improvement being happening in various algorithms, but still we have got 95%, 97% accuracy, but we have never come close to 100% yet. Okay, so there has been attempt made, but we as customer do realize, and we know that, okay, we will not get 100% accuracy, but even if I get 85, 90% minimum accuracy, I can recommend that model to my client. So once this is done, then I deploy the model to the client. So when I say deployment, the client uses this tool, and when he gives a new set of input, the model will give you the output. Okay, and that output can be used for maybe giving some offer letters to new candidates or to lateral candidates. Okay, the model can do that for you. Is this workflow clear to all of you? Can I get a yes or no on the screen?
Yes, sir.
Okay, all of you have understood? I mean, I would prefer people maybe writing something on the screen. That will help me. And those who are not speaking can commute on the chat board. Okay, fine. So this is the basis of the workflow. Okay. Now, when I come to when I'm going to show you on Python, I'm not sure how much of you are technical, how many of you are non-technical, but it does not matter, because I don't expect you guys to be an expert in Python, which is the language which I'm going to show. But I will be certainly telling you what is the outcome of that particular script that I execute, or the line that I execute. Okay. That is more important than the actual code, which anyway somebody can learn if he's a technical person. Okay. Now, let me go. Please don't worry. I'm going to share this with all of you. Just one thing, if you guys, and many of you, if you are already into this data science, you're doing some projects, one of the things you can do is to install one open source, which is called Anaconda Navigator. When you install Anaconda Navigator, you get a lot of tools. For example, you have tool called the Python Spider, which I'm going to show you. You have got the Jupyter Notebook, which is again used to execute Python scripts. And you also have something called R Studio, which is used to execute R. Now, R is another language, statistical tool, language, which is used for machine learning, right? So R is also used pretty extensively in the industries between Python and R, though Python is more extensively used compared to R, right? I talked to you about this model workflow. I talked to you about this life cycle already. Now, let me tell you something of the data pre-processing steps. Okay. So first one important, when I get a data set from my client, I need to do some data pre-processing steps. So one data pre-processing steps, number one is I have to import few libraries which are important for me in Python to execute some commands, right? Then I import my data set. So my data set could be in a Excel format, it could be in a CSV format, it could be in a PDF format. So I have to have means to import my data into the program. And once I import my data, I need to identify which are my independent variables and which is my dependent variable. And as I'm again repeating, you will have one dependent variable, but you can have as many number of independent variables or features, right? Third, if you have missing data, how do you take care of missing data, right? Number four, categorizing data. Number five, splitting the data into training and test set. And number six is feature scaling. These are the data pre-processing steps which you need to do as a part of data preparation phase before you get into the modeling phase, right? So the three important libraries which are used in Python are, one is called the NumPy, which is mainly used for numeric calculations. You have the matplotlib, which is used for graphical representation. And you have got the pandas, which are mainly used for the data manipulation. So whenever you're importing a data set in either a form of Excel or PDF, you use the pandas library, right? And then you import the data set, which you see in the command here. You identify which is your independent variable. So your independent variable starts generally is denoted by X, and your dependent variable is denoted by Y. And please note that in Python, the variable is case sensitive. So small x and capital X has different meaning. So you have to be very careful on the case that you're using. And generally we use capital X for independent variable and small y for the dependent variable. Okay. Now let me...
Sir,
Yes,
small question, sir.
Sure.
You have given that ILOC, no, sir. How it will take if it is -1, -2? If you can just little bit brief out.
Okay, this becomes a bit technical. You want to get into that? Okay.
Little bit, sir. Just give how it is taking that.
So when I say -1, when I say colon, comma, means I go through all the rows and I take all but the last column. If I got 5 columns in my data, when I say colon -1, see all the columns, that means there are 5 columns. The first 4 columns are my independent variable. And y equal to data set comma 3 is in the case of Python, the array starts from 0. So when it starts from 0, so 0, 1, 2, 3, that means my 4th column will be my y.
Okay, sir. Fine. Thank you.
Okay. Now let me go to my data set. Now this is my Python Spider. Okay. How many of you have used the Python Spider?
Sir, I do in Google Colab, sir, or Python.
Okay, that's fine. I mean, it doesn't matter. Okay. I just want to see specifically if you use Spider. Okay, no, never mind. So in this case, you have this, the left hand side is where you're going to execute the script. The top right, you have a help where you're going to get any help of any documentation. You have a variable explorer where any output of a command gets assigned to, if it gets assigned to a variable, you can see the output in the variable explorer. and the files is where the files you want to execute. So you go to a particular path and you go to the particular file which you want to execute. And typically in Python, any file with .py is your script file, okay, which can be opened here. And the bottom right is your console where you have the command. So whenever you execute a line of script, it gets executed here and goes to the next prompt. So the execution of the script happens in this console, and if there's any error message or anything like that, will all be reflected in the console. Now I am going to open a data pre-processing template. Now this is the data pre-processing template which I have. It's a ready-made script file which I have already created, and I'm going to use a data set called data.csv. Now in this particular data, now what is the problem statement? The problem statement is, I'm an automotive company, and I want to select whether a particular person is going to buy a brand of my car or not. So I capture his age, I capture the country belongs, I capture his salary, and he clicks on a button somewhere on the website, and then if he clicks yes, that means it is one yes, and if he doesn't want to buy the car, it will be no. So I capture this data, and then I want to basically come out with a machine learning model which will be able to do a prediction based on the age and the salary of an individual. Now with this problem statement and the data you see in front of you, can somebody tell me, is this a supervised data or an unsupervised data?
It is supervised data.
Okay, if it is supervised data, is it regression or classification?
Regression.
Regression.
That we cannot say, sir. I don't know.
Why are you saying regression?
Sir, if it is supervised, then classification.
Why are you saying classification?
Classify the numbers of age is the group, salary is the group.
So which is your dependent variable?
Dependent
Salary is a dependent variable.
Salary is dependent variable.
Purchasing is.
Somebody saying salary is a dependent variable. Somebody saying, so you see, my problem statement was, I want to predict whether a person is going to buy a car or not based on his profile. So my
Purchase is the dependent
variable.
Purchase is a dependent variable.
Dependent variable.
And purchase, so this is the classification data.
This will be classification problems.
Correct? This is the classification data. And which is your independent variable?
Age,
salary, and country.
All the three will be your independent variables.
Yes.
Okay. Now this is the data. So what I'm going to first do is I'm going to go to my script. I will first import all my libraries. So typically I would have selected all the lines and executed the complete code together, but I'm going to do one line at a time. So I'm going to first select this line, press Control and Enter. It gets executed here and it comes to the next one. So I imported one library, matplotlib, which is for graphical, I import here. And pandas, which is for manipulating my data set, I import here. This is my data set I'm importing. Now, when I go to my variable explorer, I will see something called a data set, and the type is data frame, which has got 10 rows and 4 columns. And if I double click here, I will see my country, age, salary, and purchased. Is there any problem with this data?
Yes, sir. Few places are NaN.
Few places are NaN. Okay, that means they are missing. So as a data scientist, what will I do?
we will remove the missing data or ignore the missing data and then use the data which is correct.
That is the first mistake we all do. As I've told you so many times, the last option you should do is remove any data.
Sir, we can take the average.
You can take the average. On what basis?
Sir, we can take the where the salary is missing. We can put the same salary by searching the same age person.
No, you've got different age, no? You've got 35, 38, 40. There are different ages. It's unique, right? So what will you do here? What will you do as a data scientist? As a consultant, what do you do first?
We take the lower and upper limit of that age, and we take then we take the average of that age and then predict, sir.
That is the last step. What is the first step you will do?
We ask for the missing data from the owner.
Absolutely. Who is the owner of the data? It is the business, it's the customer. You cannot make your own assumptions and start doing your modeling. You have to go back to the client and say, hey, what is the problem? Where is the missing data? Can you please provide me the missing data? The ownership of the data is not with you as a data scientist. It is with the client. Always remember that. You cannot afford to make any assumptions without the concurrence of the data of the client. Because the client will not sign off the data preparation phase. Every phase has to be signed off by the client before you go to the next phase. Okay, so even if you make assumptions, it may be the right assumptions, but you cannot do it unilaterally. You have to do it with client's concurrence. So first, and as rightly said, you should first go back to the client and ask for the missing data. And more or less the client may be having, okay. But in case the worst scenario, he doesn't have the data, then you can make some assumptions. And that assumptions that you make needs to be signed off from the client. You need to get a concurrence from the client. Okay, so in this case, being a very simple example, and as I'm telling you, and somebody was telling to delete the data, please never do that. That is the last option you do. Okay, so you should try to get all the missing values as far as possible, and the last scenario, in case you don't get, then you probably think of deletion, but otherwise you should never do it as a default. So once you have the missing data, so there are two options here. One is obviously get the missing data, so you're good. Or the other option here you can do, you can write a function to maybe, so one of the functions you can write is probably take the mean of the, or the average, as somebody said, of the age and fill up the missing value, or take the average of the salary out here and fill up the missing value. Okay, this could be the most easiest assumption that you can make. Okay, so having said that, now you have already done the data set. Now first I will identify the independent variable and I will identify the dependent variable. So now if I click on X, so X shows me my country, my age and salary. And if I do Y, I got my yes or no, right? Which is my guys, whether guys are purchasing the car or not purchasing the car. Now I'm using this particular text. This is already executing this. This will convert the missing values into the average. So I'm using a strategy called mean. I can also use a strategy called median. I can use a strategy called mode. I hope you guys know what is mode. Anybody know what is a mode? What is a mode?
It's a modulus.
Then what do you mean by modulus? What is mode? MODE in statistics. I'm hearing a lot of noise. Can somebody go on mute who is not speaking? Yeah, thank you. So what is mode? So mode is the maximum occurrence of a value. So if I have multiple values and suppose 10, 20, 10, 10, 10, okay, so my mode is the 10 because that is having more than one occurrence, right? So my mode is the highest occurrence of a value. So that is 10. So you can replace it by the mode or the median or even the mean, right? So here I'm using the mean. Now when I execute this line, so I will be providing all the scripts to you so you can practice it as per your convenience. So if I now go to X, now if you see that my missing values got replaced by the average of the salary here and the average of the age here. Is this clear to all of you? What I
Yes.
did? Okay. The next step which I need to do is I have got some text fields in my data. One of the most important thing is that machine learning algorithms don't understand text. So before training the model, you need to complete all the data into a numeric value or whatever binary value, or it should have numeric value. It cannot have any text value. Okay. So one of the values which you see here is called the country, which is a text value, and the other one is purchased, which is again a text value. So what I do is, so there is a function which helps you do that. I will.
तू तो हैदराबादला गेलता ना
Can you please go into mute? Yeah, thank you. So typically, suppose I have got three countries. I will explain you how the function works. So you have say three countries, say USA, India, and say Germany. Your data has got three such data. Okay. So what I will do is, first of all, I will convert this into a serial number 0, 1, 2. Okay. Why 0? Because my array in Python starts with 0. So I will have three values 0, 1, and 2, right? And then I will convert this into an array of three variables. Why three variables? Because there are three unique values, right? Now this array, how it is done is that if it is USA, I will represent it as say 1, 0, 0, where 1 represents the existence of the value, 0 means the absence of the value. If it is India, I represent it as 0, 1, 0. Okay. And if it is Germany, I will probably represent it as 0, 0, 1. Okay. So what I've done is I have converted this into an array of three variables like 1, 0, 0, 0, 1, 0, and 0, 0, 1. And this is done using a function called label encoder. And this is done, this array of three variables is done, it is done using a function called one hot encoder. Okay. And these variables are called dummy variables. They are called dummy variables. Is this clear to all of you? How a country field has got converted into an array of dummy variables. Is this clear?
Yes, sir. Yes, sir.
So
Yes, sir.
let us go to the script and see how it is executed. Now I'm going to execute. I'm going to convert this France, Spain, Germany. First, I will convert into a serial numbers, right? So I'm going to use label encoder here. So I'm going to execute till the label encoder line. And now if I go to X, We'll see 0, 1, and 2. Now you don't have to bother which is 0, 1, and 2. That the function will take care. The idea was to explain you the concept, but whether it is 0, 1, 2, you don't have to bother. Okay, the function will automatically take care of that. So now it has converted that number into a series number. So if there are 5, it will be 0, 1, 2, 3, 4. If it is 6, it is 0, 1, 2, 5, and so on. And then it will create an array of 3 dummy variables, and that is using this one hot encoder. So if I execute this, sorry, I execute this line now, and if I go to X, now do you see? Before age and salary, now you got 3 dummy variables. Okay, 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 1, 0, and so on. So every row will have, at least the dummy variables will have only 1, 1, and others will be all zeros. So 1 represents the presence of the country value, and 0 represents the absence of the country value. Because for every row, there will be only one country value, right? So that's why you'll have 1 and remaining all zeros. Okay. Similarly, your Y, which is your purchase yes or no, needs to be converted into 0 and 1. So that's where you have to use the label encoder to convert Y into 0 and 1. So now Y, which was yes and no, is now converted into 0 and 1. And this process of converting all text to numbers is called data categorization or categorizing data. This is one of the pre-processing steps. The next step is splitting the data into training and test set, which I already explained to you. Now, the way it works is, when I split the data, it creates 4 variables: X train, X test, Y train, Y test. So X train and X test is the independent variables for the training and test, training and test data, and Y test and Y train is the dependent variable of the training and test data, right? So what I do here, so here I'm using something called test size 0.2, which means that 20% is going to be my test set and 80% is going to be my training set. Now, if I've got 10 records, I'll have 8 records as training and 2 records as test. Now you see, when I execute this, it has created 4 variables: X test, which is 2, 5, because there are now 5 variables here, 3 dummy variables plus age and country, and X train is 8, 5, 8 rows, 5 columns, 2 rows, 5 columns. Y is 10, and Y test, Y train is 2, comma. Now, if you see, there's nothing after comma, because by default, there'll be only one column, right? So you don't have to explicitly write column 1. So that's why it just says 2, comma, and it is 8, comma here. Okay. So this is where you have converted your, or you split the data into a training set and test set. And the last step, which we need to do as part of pre-processing, is called the feature scaling. And what is feature scaling? So feature scaling, now suppose you have age and salary. Now age, as, or years of experience, salary, whatever you may call it. Now your age will be typically bounded by some range, say 21 to 60, working age. Your salary could be from 10,000 a month to even 1 crore a month or 5 crores a month. Now, if I were to plot this as a graph, okay, it would be very difficult if I want to correlate between these 2 variables and do a, maybe draw a graph. It would be difficult to correlate because they are in different scales. Your age is limited between 21 and 60, but your salary could be right from 10,000 to 1 crore to 5 crores or 10 crores, right? In that case, machine learning algorithm has come out with something called feature scaling, where the idea is you need to bring it to a common base scale so that the algorithm is able to do an analysis or a correlation between the age and the salary, or be able to do a basically do a graphical analysis, right? So feature scaling is a very important step. Whenever there are various numeric values with different scales, it is always recommended to do feature scaling. And there are two ways to do feature scaling. One is called the standardization and one is called the normalization. Okay, so for standardization, it uses a function called standard scaler. And for normalization is use a functions called mean max scaler. So when you use, now these are all the inbuilt functions in Python. Okay, so you can just use these functions which will help you to do the feature scaling. Okay, now let us see how it works and how the output looks. So now if I go back to my script and let me say use standard scaler, I can use either the standard scaler or the min max scaler. Both of them can be used. Okay, there is no fixed, there is no fast rule that you have to use min max scaler or standard scaler. You can use any of the two functions. So what I'm doing,
I have a question, sir.
Yeah.
If the data is categorical, then no need of scaling.
No, sorry, what is the question? Yes,
If the data is categorical, then no need of scaling.
If your data is fully categorical, then there is no, obviously, because categories have a fixed set of values, no ma'am?
Yes, sir. Yes, sir.
Here you are having values in different range. It's a continuous output, right? Your age is different, your salary is different, right? So in that case, what I have to do is you have got this X train and Y train, X train and X test. So I'm going to apply this on my agents. I will probably apply it for all the variables, all the output, but ideally I could have only applied for the agent salary. But for now, I will apply to the complete X train and X test. Now, when I apply this, and I now have to go to values of X train, you will see the value something like 0.774, 0.263. So typically the values will be between -1, -2, and +1, +2. So the values after scaling will be typical, and then you don't have to bother. The mapping of the value to the scaled value is done in the program itself. Okay. So similarly, if I do to X test, okay, I get again the scaled values for the X train and X test for the 2 records and for the 8 records. So this is how, again, using feature scaling, I try to bring those values which are in numeric various ranges to a common base scale, and that essentially is called feature scaling. So is this data pre-processing steps clear to all of you? So we talked about importing libraries, importing data sets, identifying the dependent and independent variable, identifying data categorization, fourth, splitting the data, first missing data. If you have a missing data, then you have data categorization, then you have splitting the data, and then you have feature scaling.
Yeah, once a little bit about missing data, sir.
Sorry.
A little bit about missing data, sir.
So if you remember, we had some missing data right here.
Yes, sir. Yes.
So when we had initially, we had the data set out here. When I go to variable explorer and I go to the data set, see, I had some missing data, right? So how do I take care of missing data? As I've told you, first you have to go to the client and get those missing data. And the worst scenario could be write your own function like a mean or median or mode to fill up the missing values. Is that clear?
Yes, sir. Yes, sir.
Okay. Any questions on data pre-processing before I get into regression? Okay. So
Sir,
now,
what is random state 0 stands for?
So random state 0, see, the random state will decide whether how it will pick up the values. Maybe it will take the first 10 values. It will arbitrarily select out of 10. If there are 20% tests, whether you should take the first 2 records as the first 8 records as training or last 2 records as test. So this is a random number, it gets generated internally. Okay. So it does a random state. So there are various random values and you can select whichever values, right? So And when you say random state 0, it typically takes the first top from the test training, and then the last two are test. That's how it does. If you take random states different, then it will randomly create a random number, and it will assign to the training and test set. Okay, so you can basically do more research on this if you're a more technical person, right? You can do that. Is this clear? Can we go ahead with regression?
Yes.
Yes, sir.
Okay.
Sir, classification is over. Sir, one more step in this I want. If at all you want to give a new input and find and get the classifier which it belongs to, that step is also there, sir.
Yes, so that comes as part of your model evaluation, right? So when I come to classification and all that, I'll show you. So you can,
yes, sir.
so when you give a predict value, it will give you an output value. So I'll come to that. Okay. How you do the model evaluation, I'll come to that. Yeah. Okay. Now what I'm going to do is I'm going to start with a simple regression. Now you are aware of the workflow. We are all aware of the workflow. I'm going to run the simple regression function. Very simple first. So I will go back to my regression, simple regression. Okay. And first, what I will do is I will initialize the kernel, restart the kernel. Now, what this kernel does, it will just blank out these values because it looks all garbage to me now, right? So I will just blank out this value and make a clean, fresh slate out here. So I will clean out completely while I will go to my files and I will open my simple linear regression.py. Okay. Now, before I get into the script, I wanted to explain to you this particular slide. Now, if you see, you have a salary and you have an experience. Okay, your salary is your dependent variable, experience is independent variable. Imagine that when you are testing the model, when you are doing actual test, so you have first trained the model. When you have done the training, the model has come out with a pattern where you have tried to find out the correlation between the dependent and the independent variable, right? When you apply that particular model to a new set of independent test data, you assume that this is your pattern you're getting from the model. This is the pattern that you're deriving from the model. That means after I entered my independent variable, I came out with my predicted salary. This line depicts the predicted line or the pattern which is coming out of the model. And these dots are the actual dots. And these dots are the actual test data. So in order for my model to be accurate, all these lines has to be close to this pattern data, right? This distance should be minimal. So we call this as the yi, actual test data, and this is yi caret, which is the predicted data. So the function of a linear regression model is such that it has to ensure that the sum of yi minus y predict the whole square. That means the difference between the yi and the y predict the whole square has to be minimum. And this function in machine learning terms is called the cost function. It is also called the ordinary least squares, and sometimes it is also called the mean square error. So the idea is, how do you minimize this cost function? And that is the objective of how a regression model works. So the idea is, suppose you have got theta 0 and theta 1. This is your regression equation. So the regression equation works in such a way that it adjusts the theta 0, theta 1 in such a way that will try to minimize the cost function, that it will try to minimize the sigma of yi minus y predict the whole square. And this is how a linear regression model works, right? So if I go back to my script, and let me just close this and I open the simple integration.py. Yeah, I've done that. And now this is my data, very simple data where I got years of experience and salary, right? Now see what I will do. Now, first of all, data pre-processing steps. Do I import the libraries? Yes or no?
Yes, sir.
You have to do that. Then you have to import the data set and identifying the dependent independent variable. We know that has to be done. Then third is missing data. I'm assuming here there is no missing data here, so we can ignore that. What about categorizing data? Do we need to do that?
Not necessary. Not necessary.
Not necessary. Why?
Because it is already continuous data.
No, that is not the answer. The answer is there is no text value.
Okay.
Okay. Please don't get confused with the data categorizing category variable. Don't get confused that. When I say data categorization, is there any way you have some text field which needs to be eliminated and converted into numbers, right? So you don't have a text field here. So obviously you don't have to do data categorization. Data split, is it required?
Yes, sir. It's required.
You will have to do data split irrespective. Feature scaling, is it required?
Yes, sir. It is required.
It is required because you have got both this in different range. Very good. Now let me execute this and show it to you. So first of all, I will import my libraries. I'll import my data set. Again, if I want to see my data set, go to Variable Explorer, double click on this. It will show me my years of experience and salary. Okay. Then I will identify my independent variable, which is my years of experience. I will identify my dependent variable, which is my salary. So if I go to X, this is my years of experience, and this is my salary. So total, I have got how many records? 30 records, right? Then I will directly go to splitting the data because I don't have to do data categorization. Okay, so I do the splitting the data. So when I do that, I get around say 1/3 I'm using for ease of calculation. So around 10 records of test set and 20 records of training set. Okay. Now, when I'm using the linear regression function or linear regression algorithm in machine learning, feature scaling is an inbuilt feature of the algorithm. So when I'm using the linear regression function, feature scaling is automatically taken care by the algorithm. So I don't have to explicitly write a code here of doing the feature scaling. That is why I have commented the code. This is commented here. Green means it is commented, means I cannot execute this code. Okay. So now that I have completed my data preparation phase, I've done my data pre-processing. The next step I will go to modeling, right? So now what I do is I use the linear regression function. I feed my X train and Y train. That means I feed my independent variable and the dependent variable of the training set. And this will help me regression function, which help me to try to come out with a pattern out of the data. And then what I'm doing, I'm inputting the independent variable of the test set into the model and coming out with a Y pred, which is the predicted value. If you remember, I showed you Y caret, the Y pred. This is my predicted value of the salary. Now, Y pred will be compared to what? Which variable I will compare Y pred with?
Y test.
Y test, right? So I will have to compare Y pred with Y test because my Y test is my actual test data and Y pred is my predicted data and Y test is my actual test data, right? So the one way of doing the prediction is I can click on Y pred here and I can click on Y test and do a manual comparison, right? Okay, if my predicted value, my actual value is 37,731, but for that same data, my model is giving an output of 40,800. See, it will never be same. Okay, here it is 122, it is 123. It is 63, it is 63 to 65, not bad. It is 3055, it is 64, quite a difference, right? So in a very raw sort of scenario where you have very small records, you can do sort of a visual comparison between the predicted value of y and the actual value of y. Okay. The other way of doing it is drawing a graph using matplotlib. So what I do is I draw this. So I'm taking the training set. So what this shows, for my training set of data, this blue line is the output coming out of the model. So the model is showing that this is showing the pattern between my years of experience and the actual data, salary, and the dots are the training set or the training data. Okay. And if you see that there are some points which are far away from here, and there are some points which are very close to the predicted line. Now let me do this on the test set. When I do this on the test set, the model is working pretty well for a test set, right? It has, barring one or two points, those many of the points are close or nearly on the line of the test set. So this is one sort of a visual representation. But the metrics that we use to measure a regression function is something called the R square. Okay, we call something called the R square. And the way we calculate the R square is R square is 1 minus sum of the square residual divided by sum of the square total. So sum of the square residual is sum of yi minus y predict the whole square. And what is this called? What is this called?
Square of error.
This is called the cost function or the mean square error, right? This is the cost function, right? And this is sum of the square total, which is sum of yi minus y average, the whole square. Yi predict, this is yi actuals. So if my sum of the square residual has to be, if this has to, cost function has to be minimum, then my R square value for the better, for the model to be most optimal, the R square value should be close to 1. My R square value has to be close to 1, right? So if my R square value is somewhere between 0.85, 0.9 to 1, I can propose that particular model to my client. So what I will do is, I'm going to execute another script which will show how do I calculate the R square. Okay, so everything is the same. I use the same data set. I'm just importing one more library called function called R2 underscore score, that is R square. I imported my data set. I have identified the dependent and the independent variable. Then I split the data into training and test set. Then feature scaling is not required. I then train the model. After I train the model, I do the Y prediction. Okay. Then this is what I've done. Now this is the line here. What I'm trying to do here is I'm trying to print the R2 score where I'm taking Y test and Y pred as a parameter, and it's giving me an R2 score of 0.97, which is very good. Okay. Because my R2 score is 97% or 0.97, I recommend this model to the client. So this is how I run a simple regression equation, and what I wanted to highlight here are the various steps, right, from data pre-processing to data modeling to evaluation, okay, and then finding out the efficiency of the model. Any questions at this point of time? We will stop here. If there is any question for next 1 minute, we can discuss. Then we can wind up for now.
Sir, I have a question, sir.
Yeah.
Sir, in this regression, for example, we have done for experience and salary. What if country is also there? Country name is also there. Can we do regression?
So that becomes a multi-regression.
But it is a categorical variable, no, sir. But can we do regression in that case also?
Which is the categorical variable?
For example, name of the country.
Name of the country is not a category. Is that your output?
No, no.
What
it
is the
not
analysis? It is your dependent variable has to be categorical, not your independent.
Okay. Okay.
In regression or classification, the difference is that dependent variable is categorical and the dependent variable is continuous. It's nothing to do with the independent variable.
Okay. Independent variable can be anything.
Yeah.
Okay. Thank you, sir. Thank you.
Okay. So those are the inputs which will decide the dependent variable, right?
Sir, we can use here another model for comparison with the linear regression too. Can we use?
Which one? Which one?
Like this linear regression model you have used here, right? It is giving accuracy of 97. Okay. So if we want the same thing, if we want to compare the same thing with another model, so
you can use decision trees, you can use support vector matrix model and try out whether what sort of efficiency you get.
Okay.
But for regression model, we use R square.
Okay, fine, sir.
Calculate
Sir, will you please share this code side by side in that chat box so that we can also try it?
Then I will share it at the end of. Don't worry.
Okay, fine.
You don't have time to try it between now and 2 o'clock. Right?
Yeah, no issues.
I will share with Rohit sir at the end of the day. You can practice.
Okay. Sure, sir. Sure. Thank you, sir.
Any more questions? Then otherwise, so let's break for lunch and we will assemble at 2 o'clock.
Thank you so much for your wonderful session, sir.
Yes. So let's assemble at 2 o'clock and we will continue with regression and classification, and then I will get into ANN.
Yes, of course.
Okay.
Yeah,
And maybe I may get. Do you have anything after 4? Maybe I will take a little. I will take a little more time. Maybe it may extend up to 4 o'clock. So is that okay for all of you?
No issues, sir.
Yes, sir. No issues, sir.
No issues, sir.
So let's assemble at 2 o'clock. Please have a light lunch and let's be engaged as we have been doing before lunch. Okay.
Thank you so much, sir.
Thank you, guys. Thank you. Bye.